up in the computer, and you get output. For machine learning, you've got data. You have your output, which in most cases just means you have some labeled data. You put it all in, and you get a program, or in our case, an algorithm that comes out of it. So there's two types, supervised and unsupervised. Supervised learning is you have training data. It's labeled. You know what the outcome is as you're teaching the computer what you want. You can think of this really as classifications or buckets of data. So you got a giant ball pit. You pick a ball up. This is red, and it goes in the red bucket. You pick another one. It's blue. It goes in the blue bucket. So things go in very predictable places. For regression classifications, these are your continuous variables. So time, money, that type of thing. Those are your continuous or your regression classifications. For unsupervised learning, the desired output isn't known. So you're clustering. So if you think of like user agent strings, you kind of can cluster, these are all of my Mozilla, these are all of my Firefox or Chrome or whatever it is. So you can cluster based on specific characteristics of the data. Your spam starts with supervised learning, and then when you put it in production, it still is learning, and that's based on buckets. So you can think of your unsupervised learning. Do you guys remember this in Walle? He's got a spork. He's like, well, it kind of looks like a spoon, but it kind of looks like a fork. And he's just, I'm not sure which bucket it goes into. That's your unsupervised learning. He's trying to figure out which one more closely matches. So for security applications, there are security applications out there already. Your spam detection is one of them. I mentioned that already. Anomaly detection. You're looking at your network traffic, what doesn't fit in a normal pattern. Unsupervised, you got your clustering. This is slowly building. I mean, we've been using machine learning for spam techniques for almost 20 years now. So machine learning in the security field isn't new. It's just become the newest buzzword. So if there are applications for security data out there, why am I not using security data? Why did I pick the Titanic? Because it really is easier for people to understand I'm going to live or I'm going to die. If you look at some of the data that's out there, I know this is kind of small, but we just have a URL and whether it's good or bad. There's no real features to it. We don't know why they labeled it good or bad. Or you get things like this, which has 22 different features, but it's things like an AS number or their page ranking. It's not, again, really helping us understand why something is good or bad. So showing you this with security data was a little harder to do. So I picked something easier to help explain the concepts because you guys understand this data. Age, sex, name, passenger class. It's easier to understand and get the basics down. So a moment of silence here. We are going to try the live demo. We've got to pray to the demo gods. Now I really do have to put my glasses on so I can see. So we are going to the Azure Machine Learning Studio. And to get this started, we just click for a new blank experiment. So our blank experiment gives us just a canvas to work on. All right. A moment. See, I obviously didn't make the sacrifice. Yes. All right, so now we got it, I think. All right. And that is hard to see, so we're going to make it bigger. Yes, turn off the light too. All right. You guys see it? All right. Now I'm in the dark and you can't see me, so this is awesome. Okay, so I've already loaded up my data set. You can find data sets to play with. There's a website called Kaggle, and I'll have that link at the end. So I've loaded my Titanic training set. So I'm just going to drag it over here and it gets dropped. I've already loaded my data now. Next thing that I'm going to do is you need to explore your data. The speaker this morning, Frank, when he was talking about, machine learning is not a silver bullet. This is why. You have to understand your data. If you don't understand your data, you can't train anything. So you have to know, where am I missing data? What does it look like? So the first thing we're going to do here is we're going to look at our data. We need to visualize our data to understand what we have. I was afraid of this. It's going to be slow. Okay. So on our Titanic data, and I can't move that window. The first field we have, as we are looking at this, the other thing that we need to do is decide what data is going to be important for us to make our predictions. So if we look at passenger ID, if you click on the field, it gives you statistics about your data. So you'll see here that all of our data, we have 891 rows and 12 columns. So if we have 891 unique values, what does that tell us? It's just an identifier. It's not going to help us classify anything. So passenger ID is not going to be important for us when we're looking at our data. Our survived, you'll notice that we have two unique values. We have a 0 and a 1. This is our label. We're going to need this column because this is going to tell us whether that person lived or died. So 0, they died. 1, they lived. So we're going to need this one. P class, you'll notice that we have 3 values, a 1 and minimum is 1, max is 3. So there's probably a 2 in there because we have 3 unique values. These are, what's the passenger class? Are they first class, second class, or third class passengers? This is probably important. If you guys remember your Titanic and history lessons, first class passengers were more likely to get off the boat, remember? So this is a field that we're going to want to know later. And you'll notice that there's no missing values, which is good because we don't want missing values. Name, we don't have any missing values, but they're all unique. But does name matter? All the Beths survive and all the Ben dies? Is that the way it works? No, this one probably doesn't matter what their name is. So we're not going to use that one. We're going to go on across here. Sex, male or female. Again, no missing values. This is probably important because we know more women got off than men. What about age? Think it's important? Yeah. Age is going to be important, but notice down here, we have 177 missing values. What does that mean? We've got to do something about those missing values. So we're going to talk about this a little bit more when we clean our data, but just remember, we have missing values in the age column. So sibling and spouse, and P-arch is parent and child. So if they're traveling with somebody, do you think they're more or less likely to get off? Well, I don't know. So we're going to include those and see what we come up with. Ticket is just a ticket number. We only have 681 unique values, which means there's some duplications in there, but that's still a lot. And it's probably not going to tell us much. Fare may tell us something. But if we use fare, this is also related to the class of the passenger because first class tickets cost more than third class tickets. We're going to include it, but just know that we could be skewing our data a little bit. And then the last two are the cabin numbers and where they embarked. Where did they get on the ship? Does it matter if I got on at Southampton? Probably not. It's more important to know whether I was what passenger class I had. So now we've looked at our data. We kind of understand what our data is. We kind of know what columns are going to be important to us. Or in machine learning speak, we know what features are important to us. So we've looked at our data. The next thing we do is we select. Now you'll notice that I'm searching for things up here. This is the easiest way to find things. So select, and then if I scroll down here, went too far. Select columns in our data set. Now, I need to connect things. And you'll notice that when I click on the button here, it only gives me one place to connect it. They make it very easy to know where your connectors need to go. So we've connected our data set, but we still have a red exclamation, meaning there's something else that we need to do. So we click, and you'll notice that over here we have a select column. So we're going to launch our column selector. And we're going to pick our columns. So this is what columns were important to us. Well, we knew survived was important because that's our label. Passenger class was important. Name, not so much. Definitely the sex of the passenger. Their age was very important. Whether they were traveling with somebody, so parent, sibling, or parent, child, or sibling. Ticket wasn't important, remember? Fare, we're going to put it over there even though we might skew our data a little bit, and then we don't need the other ones. So these are the columns that we think are important. Agreed? Okay. So somewhere on here I should have too far, I can't hardly see it. So we've selected our columns now. Next thing we need to do is fix that age problem. So we need to do something called clean our data. So we need to clean our missing data. So we're going to drag it over, connect it up again. So this way our data is filtering down now. So now we need to clean. Which column do we need to clean? And we're not going to do all columns. We're going to begin with no columns, and we're going to include based on the name, and we're going to find age. So that's the only one we need to clean. I'm so glad I got just the top corner of that circle. So now, how do we clean it though? So our options are, we can substitute a value. We can just delete it completely. We can remove the entire column. We can remove any row that is blank. But if we do that, we only have 891 rows right now. So if we remove them, we're getting rid of quite a bit of our data that's going to impact how well our module learns. So we're going to replace it with the median. Now, we don't want to we could replace it with a custom value. We could say replace it with a 0. But then we've skewed our data towards the younger end. If we say replace it with 75, we skew it the other way. But let's pick the middle, and it will automatically calculate what the mean and the median is. And we can go back up here and see what that is. So if we go back to our visualize, uh-oh. Slow network. I shouldn't have done that. It's just going to have to go. It will eventually come up, but if you go into the visualize, it will give you the mean. So if you go back to the age, and our statistics, age, you'll notice that we have almost a pretty standard distribution, meaning that most people fall between 16 and 40. And if you look up here, it tells us that our mean is 29 and our median is 28. So mean and median are fairly close together. So we're just going to use the median. We're going to use 28. But it can do that for us automatically. So you'll notice over here, I picked median there. So we've now cleaned our data. What do we need to do next? The next thing is splitting it. So when you're doing your training on these, scroll down, nope. I can't see where my thing is here. Oops, that's too far. So need to connect up. We're going to use our, that's really small. You guys can't see it now and I can't move. All right. So you'll notice that we had two buttons here. One is our clean data set and the other one is a transformation. We didn't do a transformation. We're just using our clean data set. So this is the one that I'm picking, the side that I'm picking. So now we need to split our data. This is whatever you think is best. You know your data. So academics like to do 80-20. Some people like to do 75-25. But what we're doing is we're splitting into a training data set and a test data set. So our training is what we're going to use to train our model so it can figure out which features are important. The test piece is to test how well our model learned. So I'm going to split it 80-20 just because I like 80-20. And then you've got some other things here like randomize the split. You can start it with a seed so that every time you split it, you get the same thing. I'm going to randomize the seed so that anytime I run this, the data is going to look a little different. Means we get some different numbers at the end, but for this example, that's okay. So now we've split the data and we're done with our data piece. Now we need to start looking at our classification algorithms. So we're going to look for train the model. And you'll notice down here, where's my training? Train model. Now we're going to do this twice. So I'm going to put two of them on here. So we need to connect. And you'll notice again, it makes it so that I know where my connection goes. So you see that when I do this, I have two green dots. So I am going to connect this twice so that our training data goes to both of our training model modules. So now we have our training, but you'll notice that there was another dot here. What else do I need? Well, I need to know how to classify it. So I'm going to look for our classification. Now this is where, what does all of these mean? And this is one of the reasons why I went to class. So you've got a lot of options here. We know that our data has it's a two-class problem. You live or you die. So I'm not going to use any of the multi-class. So I'm going to look at these two classes. Then which ones of these do I think is better? Pick. You can't go wrong on this. If you don't like the answers that you get, you can come back in and pick another one and look at it again and see if it does any better. So your Bayes, this is what does like your spam filtering. That uses a Bayesian model. Boosted and decision trees, this is where you start male, female. That's a decision. And then it goes down a tree. If it's male, what was your age? That's another decision and it branches out. So it creates a tree. Decision jungle just means you have a bunch of decision trees. So you can go and read what all of these are. We're just going to pick two. Let's pick a decision forest. And let's go ahead and pick a neural network. You guys, this is going to get messy, but let's take that back over. Try to keep this a little clean. Okay, so now we need to connect that up there. And we need to connect this one up over here. We still have a red exclamation point, though. So what else do we need? We need a value. So if we click on this, we need to pick a selector. And tells us launch the column selector. This is where we need to tell what our label is. So our label data is the survived. So we've done that one. Gonna do the other one. Okay. So we have 2 models now. We've trained them. We've given them data. We need to next do a score. How well has our training module worked? So we're going to score first. And we need to do this twice. We need to have one for each one. We connect this up here. And this one over here. Now, when we split our data, this is where that test data set comes into place. So you'll notice that we can come and take this over, click the button over there. So now our test data is going down to our scoring. So now it's going to evaluate how well it learned when we trained the model. And then the last piece is to evaluate. Which one of these is better? So we're going to evaluate both of them. And that's it. We've built a machine learning model now. How well does it work? So let's run it. Oh, I missed. You're right. Thank you. And you'll notice it didn't run. Okay. So now we run it. It's going to take it a few minutes, but it is going to come up. You'll notice that we start with clocks. That just means it hasn't got to that point yet. Green check marks mean that it passed the test. If you see one of these probably has a spinning, there it is, the spinning means that's the piece that it's working on. This usually takes anywhere from 30 seconds to 2 minutes. Any questions why that's running? Pretty clear so far? Not the magic that the vendors will let you think it is? Yeah. I run this all the time and haven't ran into any charges yet. So, but I don't know if that's just the license. I ran it through school and I'm running it through work and I haven't ran into any charges yet. So I can't answer that question. All right, we're done. You notice that we got green check marks. So we finished it. Now let's see how well we did. So right click and you go to your evaluation results and visualize. So blue is always the one that was on the left. The reddish maroon color was on the right. So it starts with the blue. This is the blue line. And down here, it gives you a bunch of numbers, which I could go into the math behind all of those, but then we're going to be here for a couple hours and nobody wants to get into the math piece right after lunch, right? So we're just going to focus on the F1 score. Just know that F1 score balances your recall, accuracy, and precision. So that's the more balanced score that you need to focus on here. So what I do on this side, the decision forest, our F score was 68. So not bad. This part over here, this is called your confusion matrix. So how many did it get right? True positive. How many did it get wrong? Which was your false positive. So there's your confusion matrix, and it does get pretty confusing. Oops, I closed that and I didn't mean to. Sorry about that. So if you want to look at the other one, So let's highlight the maroon one, and you'll see that our F1 score on this one is 71. So the neural network did slightly better. So that's the one we're going to keep. So now we know which one we're going to use. So we're going to get rid of these other ones. We don't need the evaluate anymore. We don't need the score. We're not going to keep that one, and we're not going to keep that one. So let's move these things over and make it a little cleaner. Now, since I deleted things, I have to run it again. Make sure I didn't introduce any errors to it. We're good. That one ran fast. Like it. So we're now ready to start looking at this as a web service. So we're going to set this up as a predictive web service. You'll notice that when I do this, it's going to go through some transformations here, does some things, it's packaging things up, and I come up with something that looks a little bit different than what I had before. Once that's done, I have to run it again. What it does is it's going to make sure that the transformations that it did didn't break anything. So it's running again. You'll notice that it's running up here. Okay, we're finished. No errors. Everything is green. So now let's deploy it as a web service. We are now ready to run data against our model. And you'll notice that we have an API key, so we could set this up as a website if we wanted, but I frankly don't have time to code a really nice web page for this. So what we're going to do is use it under an Excel. So we're going to download this Excel 2013 or later. Yes, I'm going to have sample data. And I'm going to save it, not there. I'm going to save it under here. And I've learned that sometimes if I click on it down here, it gets confused. So I'm going to open it from here instead. And this is just going to be an Excel spreadsheet. Now, this is where I'm going to tell you to do things that as a security professional make me horrified. But we're going to do it anyway. We're going to enable editing. We're going to click that button. And then the next thing we're going to do, the other box, the first time that you run this, the other box that pops up says, do you want to install this add-on from Office? Be a user. YOLO, click it. Do it. So I have that loaded on here too. So now I'm going to tie my Excel to that predictive web service that we just created on Azure Studio. And you'll notice that it's now connected and I have other things that I have to do. I'm going to say use sample data so I can just see what that data was like from our training set. And then I'm going to pick a row here, and I always do this backwards, so I'm going to actually try to be smart about this today. I'm going to select this row. This is where I'm going to type in my data, and I'm going to say my data does not have headers, and my output is going to be down here on 15. So I think I can just type in A15. Don't include headers on this one. And I want it to auto predict. So as we're typing in, it should start doing our predictions. Now, if I didn't screw this up. So passenger ID, we know that we don't have a passenger ID. Survived is what we're actually trying to predict. So I'm going to leave that one. I am a first class passenger. My name is Beth, and you'll notice as I'm doing this, it's checking. I don't have enough in here yet for it to do the prediction. I am female. I will tell you my age for another 4 days, by the way. I am traveling alone. So I have nothing there. And you'll see, again, it's predicting, thinking about it. And then how much did I pay for my fare? I paid $75. I now get a percentage. I am 94% likely to survive the sinking of the Titanic. But I can change these values now, and it will change this. So if I change this to male, 24%. It is now making calls out to our algorithm to figure out what our survival rate might be. And you'll notice that I could make this anything, and it doesn't change that because name wasn't important. But traveling with passengers or with parents or child, for a male, it doesn't change. It changed it a little bit from 24 to 26. What if I change this to a third class passenger? Ouch. 4%. You're probably going to die. So that is how that works. That it's making predictions based on our training set of data. So you can sit here and you can change these values however you want them. What if I change this back to female? 34%. What I learned from doing this, never travel third class. Always travel first. Because if I take that to first class, I'm at 93% now. Just changing the passenger class. What about second class? Oops. Wrong field. 93. It just dropped it just a tiny bit. Pretty cool, huh? You've just created your first machine learning model. So let's go back to the slides. Now if you want everything that I did, I put in my slide deck just in case something broke and I couldn't do a live demo. So if you're interested in trying this, just let me know. I'll send you the slides. 'Cause it's all there. And I also had something in here. Remember I talked about precision recall? This was a slide it helps kind of understand what it is. There's also some links to articles to help you understand it better. So, all right, links. So here's the resources. So if you want to try to play this on your own, come on. All right. So the link, if you want to try this, is the Azure Machine Learning Net. Kaggle is where I got the Titanic Dataset. They have a bunch of other stuff out there. So if you're interested in learning this and doing some more, they have all kinds of data sets out there that you can play with. They also do competitions. So if you start playing with this, you can submit, you can create your model, ensemble, whatever you want to do, and submit it to the competitions. I wanted to show you this one. This is probably going to break again because I didn't do this before. Yep. All right, go back. Duplicate. So what we could have done is done something really. Thank you. All right. Data Science Dojo, they built something around the Titanic data. You know, I said you had an API key. you could build something like this. And it does the same thing that our spreadsheet was doing. Was it first class, second class, third class? I'm female. I'm old. Not that old. Traveling alone. And I pay, what did I say, 75? Now, we're going to get a different answer than what I did because they use different features. This one says I have a 24% chance of surviving, where on the one that I did, I had, 93, 94%. So just different features. They picked probably a different classification than what I did. So that's where you can get different answers. So you can play with that one. Again, that link is out here on the slides also. And then again, accuracy, precision, recall, a couple links to help explain what those are instead of just saying use the F score. Last thing I want to leave you with, I found this one really funny. It's a little blurry. So there are many different types of machine learning things out there, and it's being used more and more. So if you think of your self-driving cars, that is using a visual machine learning. Is that a person? Is that a lamppost? Is that a mailbox? It is using the machine learning and the visual pieces of that for the self-driving car. You've got voice recognition, your prompts on the phone systems and how to get it routed to the right place. That's using machine learning in the background. Amazon's recommendation engine, Netflix, you should watch this next. That's all built on machine learning. So there's a lot of things that are out there. But if you put all of those machine learning pieces together, you end up with the Terminator. Just remember that. So, thank you. Are there any questions? Anything I can try to answer?
To drag and drop columns. Is that something that you install on your laptop and talks to Azure or the cloud?
No. So the question was, what was I using to do that? That was actually in the cloud. That's the Azure Machine Learning Studio. And that was that first link on the resources slide right there. That's where I went.
Once you created your model, is there a way to assign weights to what matter goes? Like how to track? Can you see them?
Yes, you can change the weight. So on the features that we selected, can we make a weight for changing which features are more important than others? Yes, you can. That's getting into the more advanced stuff that I thought might be a little too, it'd take me too long to get through all of it.
But after you're done with your model, you just see the predictive outcome of how much this enforces the outcome, right? Versus maybe age versus sex, right? Can you see the way it goes?
Which is more important on those in the decision tree? There is, I'd have to go back. I've looked at it, but I can't remember where I found that. It's under the evaluation piece. And it was something selected on, how I was selecting the columns and things. It was something on that side. I'd have to find it. If you email me so I can remember to go look it up. It is there. Yeah. Yep. And one thing I didn't show is, if we weren't happy with the results that we were getting, we could have went back in, if we thought that fair was influencing it too much, we could have went back in and unselected that and ran it. You can change any of that stuff before you do that transformation to deploy it as a web service. So you could have went back in and edited any of those things if you didn't like how it was working, if you thought you could do better. 71 for that F score, it's a little better than guessing. But it's not, when you're actually deploying these, you're going to try to get that F score up to 85, 90, somewhere in there, so that it's just a little bit better than guessing. I didn't play with this one as I was doing this demo to try to get that F-score up. For me, it was more important to get through the demo than it was to try to get that F-score higher. But if you're going to do anything with this, you're going to try to maximize that F-score. Good question. Thank you. Anything else? Yes. Okay, I caught about half of that, so Mm-hmm. So, the question was, as I went through and I selected columns, I realized that it wasn't working as well as I thought and I needed to add more data. How did I know that? If I couldn't get that F-score up where I needed it to be, I realized that I don't have all the data. So a good example of that was, in one of my classes, we were playing with, coaches' salaries and what impacted how much a SEC football coach salary made. And it wasn't just a factor of school size and grades. We had to get, how big was the football stadium, how many fans would come, endorsement contracts. So at that point, I couldn't just go out to the NCAA and pull down their salary information and school information. I actually had to scrape the Wikipedia page to get stadium information to know how many fans would come to a game. And then I had to go scrape another website to get data on endorsement money that they might be making, because that's all has to be reported. So, the first one is like, oh, I can do this. I can just check student body population, athletic performance, and athlete grades, and maybe figure out a salary. But when I couldn't get that F-score up, it's like, okay, well, now I need to add more data sources and figuring out how to add that data in. So why would I exclude it? If it's not bringing me, again, it's that F-score. If there's too much jitter in there and I can never get that F-score to stabilize, I can also not just add data, I can remove data. So if we had put name in there, that would have caused too much jitter, because name really doesn't mean anything. You can't tell anything by the name. Even if you think, oh, well, we can tell that's a female name versus a male name, you've got names in there that are like, Mrs., instead of using their Mrs. Beth Young, it's going to be Mrs. and the husband's name. So it's very hard to just pick out the name and know whether it's male or female. So it's going to cause too much jitter in the data.
So why does it help judgment? You would put that as a way of name, put it down basically.
That's where we need to know our data. And for them, it's just a feature that yes, on a neural network, that is going to drop on that jitter. It will start ignoring it. But if we know that it's going to cause a problem to begin with, why include it? It's just one thing that we don't need to include and look at. Mm-hmm. So other things that are, again, I picked Azure because it was drag and drop, fairly easy to understand. The industry standard is going to be using R. So look at RStudio. You can also, there's Python. Google has it's Google code. I can't think of what the URL is off the top of my head, but Google has a place kind of like this where you can log in using it. Again, I used it through school, so they had G Suite. But it's a place where you can type in Python code and run it. There's also a drag and drop, I think, in there. Yeah, I prefer RStudio for that. I was trying to think of the other. I just lost it. It's another cloud solution, but IBM has one. I just forgot it. No, it's not Watson, but it's like it's gone now. Sorry. But IBM has a solution if you look for it. But again, that one's in the cloud. So on the machine, I would run RStudio or Python. Anything else? Okay. I don't think I put my email address on here anywhere. How about I add this? You can find me on Twitter. Remember my own email address. You can find me there too. Make it bigger so you guys can see it.